In this video, we are going to talk about work. So work is basically the total amount of effort done to perform a task. And basically us knowing what work is in everyday life, that we're doing work, I am doing work, people are doing work, people go to work, and you're basically putting some sort of effort to do something. So if we want to be able to quantify this a little bit more, we would say that the work is equal to the force times the distance, where this force is some sort of push or pull. So the force, as what we've talked about, is measured in newtons. Okay, and this distance, let's say it's measured in meters. So usually when you multiply newtons and meters, you're going to get a newton times a meter. And there is a special unit for this, for work, and it's called the joule. Okay, so this is how many joules are used to measure work. So usually if you have SI units, so let's just write SI units here, then you would be using joules. Now, not always is that going to be the case, because if you're using the US customary system, well, force in this case is measured in pounds, and our distance is maybe measured in inches or in feet or in something. So what you will just have instead is just a foot times a pound. Notice this is not equal to a joule. It's something, it's just a feet times pound. Okay, so these are just the two different types of units that you're gonna maybe encounter in order to measure work. Now, something else to really take into consideration is that our force is also equal to our weight, which is basically m times g. So m here is just the mass, okay, and g here is the gravitational acceleration, so which is equal to 9.81 meters per second squared. Okay, another thing to kind of note about weight and mass: weight is not the same as mass. Okay, your weight actually is a force. Okay, and if you're given pounds, for example, this is already a force, so you do not need to multiply it by 9.8 because it's already given to you in pounds. If you have kilograms, then you can go ahead and multiply it by whatever g is, but just be very careful when we're given pounds versus when we're given kilograms. Okay, so if you want to write it like this, so if you have force, you can be either given to you in kilograms, so that means you're gonna have to use mass times the gravitational acceleration, or you're going to have the pounds. Okay, so let's just say F equals mg, F times g. M is just mass given to you in kilograms. This is meters per second squared. This will give you a newton. This one, if you're given pounds, that's just the force. You don't have to multiply by anything. Okay, so let's do a couple of examples using this formula. So here's my first example. Okay, so let's say we want to quantify the following thing. So how much work is required to lift a 1.2 kilogram book and stop here, off of a floor to put it on a desk that is 0.7 meters high. And we are given that the gravitational acceleration is 9.81 meters per second squared. Okay. So here we're looking for how much work is required to lift a 1.2 kilogram book off of a floor to put it on a desk that is 0.7 meters high. Okay, so let's try to figure out what exactly we have here. So the first thing to notice is that we are given this thing 1.2 kilograms. So kilograms is a measurement of mass. Okay, so m here is just kilograms. So mass is going to be equal to 1.2 kilograms. All right, and how high do we want to put this desk? We're going to put it 0.7 meters up. That is actually our distance, so our distance is just 0.7 meters. Okay, and we want to figure out how much work is required to do this type of task. So we know that our work is equal to, let me change a different color. So work is equal to the force times the distance. Okay. Now, notice that we have our distance. Our distance is just 0.7, but we don't have our force. Our force is not this 1.2. This is our mass. So how do we relate mass with force? Well, we know that the force, or the weight of this particular object, is going to be the mass times the gravitational acceleration. So our force, so let's first find force. Force is going to be equal to m times g. M in this case is equal to 1.2 kilograms. Okay, g in this case is equal to the gravitational acceleration, 9.81 meters per second squared. Okay, when I multiply this out, I'm going to get 11.772. And because it's a kilogram times meters per second squared, that's equal to a Newton. Okay, now that we have our force, now we can figure out what our work is. So our work, which is basically equal to W, is going to be our force times the distance that I'm taking this particular object. So our force that we're exerting, that this book is exerting, is 11.772 newtons. Okay, and I'm going to multiply it by the distance, which is going to be 0.7 meters. Now, because this is a Newton and this is a meter, we know that we're going to have a joule. So this is going to be equal to 8.2404 joules. Whoops. Oh, yeah. Joules. So you can write it like this if you want. You can write joules, or you can just write it as 8.2404 and then with a J. My J's are kind of curly. Okay. So this is basically one of the most easiest problems for work, because work in this case is constant. Now, work is not always going to be constant. Sometimes the force is going to be changing at each for every movement that I for the distance that I travel. So sometimes if force is not constant, okay, so if work is not constant, okay, so if the work is not constant, and usually what happens here is, i.e., maybe the force or the weight is changing, because if there's changing at every particular distance, then instead the work is going to be a little bit different. The work is basically going to be equal to the integral from A to B of the force dx, where here A and B is how far I am traveling. So this is what you're going to be using if the force itself is not, if the work is not constant. So if something is changing, so for example, if you have like this leaky bucket and water is continuously draining out of this bucket, then you're going to have different weight, and that's going to be affecting the amount of work. You can imagine that the work, it might be a little bit easier if something is not as heavy. So work is not constant. This is how we're going to go ahead and do it. Think about taking in each individual piece, adding them together, and then summing up all the forces. You're just going to get the work. Okay, so in the next video we'll do a couple problems on how to do work when it's not constant.